Chapter 3, Pressure and Fluid Statics. Okay, class, today we're going to imagine we are swimming in a pool. You've probably felt that when you go deeper into the water, your ears start to feel a little funny. That's because water is pressing harder on you the deeper you go. This invisible hand that pushes on things in water or air is called pressure. Pressure is just a way to measure how much force is being pushed on a certain area. Imagine when your little brother steps on your foot with 1 foot, it hurts more than when he stands on you with 2 feet. That's because the pressure is bigger when all his weight is on a smaller area. When we talk about pressure, there are different kinds. There's absolute pressure, which is counting everything, including the atmosphere. There's gauge pressure, which is like when you measure air in your car tires, it doesn't count the atmosphere. And there's vacuum pressure, which is when you go lower than atmospheric pressure. Like when you suck air out of a juice pouch and it shrinks, the pressure inside becomes less than outside. Pressure doesn't care which way you look at it, it pushes equally in all directions. If you imagine a tiny balloon in water, the water pushes from the left, from the right, from the top, and from the bottom all the same. That's why pressure is a scalar, not a vector, meaning it only has size but no direction. Next, if we go deeper underwater, pressure gets bigger. Think about it like stacking blocks. The more blocks you stack, the heavier it gets on the bottom block. Water works the same way. The deeper you go, the more water is above you, so the more pressure you feel. But sideways in water, nothing changes. Water doesn't push harder just because you're moving sideways, only when you go deeper. Now, imagine you're at the beach, putting a tube in water. The air above the water is also pressing down, and the water itself pushes upwards. People long ago figured out how to measure this with barometers. It's just a tall tube with mercury that shows how heavy the air is pushing. If you used water instead of mercury, you'd need a really tall tube. We can also use manometers. These are simple U-shaped tubes with water or oil inside. If you blow on one side, the fluid moves, and you can see how much pressure you created. That's like when you blow up a balloon and you feel the air pushing back. Sometimes when water presses on a wall, like in a dam, the force is not the same everywhere. It's stronger at the bottom where the water is deeper. So, if you imagine the wall is being pushed by thousands of tiny hands, the ones at the bottom are stronger than the ones at the top. Engineers use this idea to figure out how thick to make the dam so it doesn't break. When you have a flat wall, figuring out the total push is pretty easy. But if you have something curved, like a big bowl or a submarine, it's a little trickier. You have to think about pushing sideways and upward separately. The sideways push is like pushing a door. It depends on the flat side of the curve. The upwards push is just the weight of the water sitting on top of the curve, like how a balloon in water feels lighter because water pushes it up. This is also how boats float. The water pushes up with a force called buoyancy. If you sink something like a stone, it sinks because it's too heavy for the water to push up. But a boat, even though it's heavy, pushes away a lot of water, and that makes the water push back enough to keep it floating. Sometimes we also talk about acceleration. Like when you take a bucket of water and spin it, the water climbs up the sides because the spinning makes the pressure change. Or if you accelerate forward in a car with a cup of coffee, the coffee tilts backwards because the pressure is changing from the acceleration. So you see, fluids aren't just boring liquids sitting around. They are full of invisible hands pushing in all kinds of fun ways. Whether you're swimming, blowing balloons, driving cars, or even building dams, Understanding these little pushes called pressure helps engineers make safe, fun, and useful things.